Good morning all. We're ready to jump right into solving equations with radicals today. So let's just get right to it. All right, so we want to talk about the power rule. Basically what it says is that if you have two sides of an equation, you can raise them to the same power and still find the solutions, and that's sometimes a good way to solve them. So when we have a question such as this, our way of solving, in order to get rid of the square root, what we can do is square both sides and we're still going to be able to find solutions. We do have to keep our eye out for extraneous solutions, but it is a good method in order to solve. So if I want to do this, I can square both sides of the equation, thereby getting rid of the square root, because the square root squared gives you the original number. And then you have something that's more manageable to solve. You can take away 4 from both sides and divide by 3. And then when you plug it back into your original equation, you check to make sure that nothing cropped up that was weird because you had to square both sides. So we plug it back in. 3 times 20 is 60. 60 plus 4, square root 64 does give you 8. And your answer is solved and you've gotten the right answer. Okay, we can use that strategy on other types of problems too. We could square both sides right from here, but that would give us something very complicated. So you want to try to isolate your radical first before you do the raising of a power. So you move the 3 over. Move the 3 over is a really terrible way of putting that, but we move it over because we can subtract from both sides. And when we subtract the 3 from both sides, we end up with something that we can square easily. So when I square them, I get a number that's easy to solve for. Add to 1 and then divide by 5 and we get 2. Which, sorry, I have this double covered. Wait a minute, you have no solution. Yes, I do, because when I plug that in and I try to solve this, I plug in 5 times 2 minus 1, and I solve it. The square root of 9. Now we're talking principal square root here. We're not looking for both sides of it. We're thinking about just the principal square root when there's no minus in front. And I take the square root of 9, I get 3. So 3 plus 3 is 6. So the problem is that in the squaring of both sides back here, it turned a negative into a positive, which made it so that we have a problem and we aren't really getting the answer that we were looking for. Okay, so you do have to plug back in and check for extraneous solutions. Always go back to the original though. All right, let's look at another one. If we want to solve this one, it's already in square root form. It's already by itself isolated, so we can square both sides. Don't forget, by this point you shouldn't be making a mistake with squaring x plus 2. Okay, x plus 2 times x plus 2 is x squared plus 2x plus 2x plus 4, which simplifies to this. We then need to subtract 4 and add x to both sides. When I subtract 4, the 4 disappears, and then I add x, we get 5x. And I want to solve this. I can simply factor out the x here. So we have two possibilities. We have x equals 0 or x equals 5. Here's my, if you need to see this multiplied out, in case you forgot that x plus 2 times x plus 2 gives you this. Just be careful with that. Then you'd need to check both of the answers on that one. Okay. Once again, I covered up too much, so we'll just do this again. Now when I check in the original, okay, x being 0 actually gives you the square root of 4 equals 2, which is right. So x equals 0 is actually the answer we checked, so that's one of them. The reason I have this written as the answer is because over the years, people have written down, because they put in the check, written down 2 as the answer. The answer is x equals 0 here. When we check this one in the original, the problem is that this is meant to be a principal square root with no plus or minus in front of it. So the principal square root of 9 is 3, not negative 3, so the answer over here is extraneous. Okay, so you have to plug back in to make sure that no negative positive issues happened. Okay? All right. Here, once again, we can square both sides of this thing. We're going to do that. Our radical is already isolated, so we can do that. Don't forget that x minus 1 times x minus 1, if you did that out the long way, you'd get x squared minus 2x plus 1. If you want to take a second to do that, you can feel free. I then have quadratics in play, so I want to make a 0 on one side or the other. So if I subtract x squared from both sides, then they completely eliminate. If I add 2x to both sides, I get negative 2x. And if I subtract 1 from both sides, I get 8. And that gives us a 0. And then I can subtract 8, bring it back over, and very nicely get x equals 4. And when I check that 4 and I plug it back into the original equation, 4 squared minus 4 times 4 plus 9, I find out that the square root of 9 equals 3, and that is a true statement. So this answer actually worked. So squaring is a really, really good way to solve these problems as long as you're careful to check afterwards. Cubing also can work. Okay, if you have a cube root, you cube to get rid of it. And so I cube both sides. And I have this. I can take away x from both sides, and then I can add 6 to both sides, and I get x equals 11. I plug it back into the original equation so that I have x, the cube root of 16 equals the cube root of 16. I don't need to simplify further than here. Even though, yes, I could look to see the fact that I've got 4 2's here, 4 2's, bring it out, be 2 cube root of 2. But I can see right here they're the cube root of the same number, so I don't have to simplify fully during a check, as long as you've got something that's identical on both sides. Okay? Sometimes things get really crazy. This one's going to take a lot of work, so I'm going to show you the long way of doing it by hand, and then we're going to use the calculator to be able to show you a shortcut on it or a different way of doing it. Now, let's just go through this. Okay, so first of all, I moved this over so I have an individual square root on one side. It's going to help us, but it's still going to get a little tricky here, because when I square both sides, I have to take 2 minus the square root of 3x plus 4, and I have to multiply it times 2 minus 3 times the square root of 4. And what that gives me is that you've got this one gets squared, then you've got 2 times this and 2 times this, which gives me 4 times this, and then I've got this one times itself, which gives me 3x plus 4. After that, I need to try to isolate this new radical. Okay, so I'm going to subtract the 3x and get 5x. 4 plus 4 is 8, so then I need to subtract 8 from both sides and get minus 2. Then I need to divide both sides by negative 4. When I have done that, and I've divided both sides by negative 4, I make this into two fractions. negative x over 2 plus a half. Now some of you are already thinking ahead and going, oh my gosh, I've got to use fractions and I've got to square this thing. And yeah, we do. So I have negative x over 2 plus 1/2 squared, and I have squaring this side. So negative x over 2 times negative x over 2 is x squared over 4. Multiply these two to get negative x over 4, but there are two of them. And then at the end you've got plus 1/2 times 1/2, which gives you a fourth. All right, then we need to appropriately handle moving this all out of the way after we get rid of these fractions. Okay, these fractions are in the way, they're annoying, they make it really hard, especially with a quadratic. So if you multiply everything on both sides by 4, multiply everything on both sides by 4, it's going to get rid of your problem. So you have x squared, 2x, 1, 3 times 4 is 12, 4 times 4 is 16. Then you can slide the 12x and the 16 over by subtracting. Negative 2 minus 12 is negative 14. 1 minus 16 is negative 15. This one factors nicely. And so your two possible answers are 15 or negative 1. Then you can check those things. So the next slide has the checks on them. And the checks are going to show us that the negative 1 actually works when you go back to the original. And the 15, when you plug that in, we have a problem. And we end up with 16 for an answer. So that one does not work. Okay, with all of that squaring, you've got some negative issues that ended up just messing that up completely. And so just x equals negative 1 is your solution. So let's check that out and see what would have been an easier calculator road. Okay, so we would put in this on one side, y equals this. Here's that part. And y equals 2. Make sure all your plots are off. If the plots are not off, don't forget you can always go back in and turn your plots off with, you can either go into stat plot to turn them off, okay, to make sure that all of these are off, or if you're in the y equals, you can do a shortcut, and if you just hit enter on any of these blocks there, I've turned some plots on. But if you want to make sure they're off, you can hit enter again and just quickly turn them off so that all of these are clear on the top like it is in the picture right here. So after you've done that, you want to zoom 6 it. And you'll take a look, and when you zoom 6, you'll have a graph that looks like this. Notice that this part of the graph is only going up like this because it is a square root function. It doesn't come down around because we are looking at just the principal square roots. There is an intersection, so we can do second calc, choose intersect. And if you remember, this is the one where you have to choose the first curve, hit enter. The second curve, hit enter. And then for guess, you hit enter one more time. And it'll give you the intersection, the ordered pair negative 1, 2. It's not the y part that gives you the answer, it's the x part. So x equals negative 1 is the only solution. Okay, you can almost imagine this graph going down, and you could imagine a possible second solution if this were down at the other part, but it's not. So that 15, that x equals 15 is just kind of way out of bounds just because of all the squaring that we had to do. So x equals -1 is the only actual solution here. Okay. All right, so here this is just the calculator sequencing if you wanted to jot that down so you have it. So the answer is what x equals. And if it did intersect in two places, you would have to do it twice, but on this one it just intersected in one place. Okay, one more. What if they're all variables? Okay, we've done all variables before, so you can square both sides. And you're supposed to be solving for c. Well, c is in the denominator. We need to make it so it's in the numerator, so we'll multiply both sides by c and divide by z squared. And you can have that. So we ended on a nice, easy one. All right, so there you have it. You do have an assignment that you need to have ready to turn in Monday. And I will hopefully very soon have an end game plan for you guys. So I'm working on that. Mr. Newman has given us the dates for final exams and whatnot, and seniors last day and all that. So I'll be getting the plan to you for those different things very shortly. All right. Have a great day and God bless you.